So based on the completion of the reactions here, so three types are there: very fast reactions, very slow reactions, and moderate reaction. And next we discuss about the rate of reaction. So what is meant by the rate of reaction? What is meant by the
The change
rate
in the
of reaction?
concentration of reactants and products.
Very good, ma. So change in concentration of the reactants or change in concentration of the products along with the time is called as a rate of reaction. Okay. So generally, how you're going to represent the rate of reaction? Rate of reaction can be represented with delta R by delta T is equal to R delta P by delta T. In this one, delta R is nothing but it represents as a change in concentration of the reactant, and delta T is represented as a change in time, and delta P is divided by delta T. Change in concentration of the products by change in concentration of the time also. Okay. Graphically also we represented. Okay. So we wrote graphical representation also now. I gave some graphical representation. So what is the graphical representation? Is let us see here with the reactants. The concentration of the reactants are decreases along with the time here. Okay, that we are going to be represented with the graph also. And another one. So if you see the products, if you see in products means here, concentration of the products is going to be increases along with the time. The concentration of the products is going to be increases along with the time. That is also we can consider it as a change or rate of reaction. What are the units of the rate of reaction? What are the units of the rate of reaction?
Mole liter inverse by second inverse.
Very good, mark. So mole liter inverse and second inverse is called as a units of the rate of reaction. Okay. So while rate expression, while writing the rate expression, okay. So that means for reactant decrease of the concentration of the reactants. Okay. We are representing with the negative sign. We wrote as a negative sign and positive sign. Negative sign, it represents what is the negative sign? What is the main importance of the negative sign in rate of reaction? Study, Aditi.
Decreasing concentration of reactants.
Very good, Ritu. Very good, Ritu. So negative sign is it represent as a decreasing concentration of the reactants. Okay. At the same time, that is only we can call as a disappearance of the concentration of the reactants. Disappearance of the reactant also we can represent with the negative sign. Appearance of the product also we can represent with the positive sign. Disappearance, appearance, are decreasing or increasing. Okay, so decreasing of the concentration or disappearance can be represented with the negative sign. Appearance and increasing of the concentration of the products can be represented with the positive sign. Got the clarity? So based on that one, again, we have two types of the reactions. Okay, how many types of the reactions are there? Two types of the reaction. So what are the two types of the reactions we are having means here? Instantaneous reaction. One is instantaneous reaction. Instantaneous reaction. Okay, so one is here instantaneous reaction. So what is mean by the instantaneous reaction? What is mean by the instantaneous reaction? So what is mean by the instantaneous reaction means change in concentration. Change in concentration of reactant or product by unit time. Okay, by unit time is called as here instantaneous reaction. Sorry, ma. So this is the ma. Sorry, 1 second here. Instantaneous reaction means here. So change in concentration of the reactant or change in concentration of the product by a small interval of the time. A small interval of the time. Interval of time. So that we can call as an instantaneous reaction. Okay. Now, here, what is mean by the average reaction? Average rate of reaction. So we have instantaneous reaction average reaction is there. Instantaneous reaction can be represented with dx, small change in the concentration. Okay, a small change in the concentration of the reactant or product by a small interval of the time is called as a instantaneous reaction. So this we are representing with dx by dt. Yesterday I asked this one only. Differentiation. Differentiation means small difference, Aditi, here. Okay, and average rate of reaction. Average rate of reaction. That is also we finished the average rate of reaction. So what is with the average rate of reaction? What is the average rate of reaction, ma? How you are going to represent the average rate of reaction? Average rate of reaction can be defined as change in concentration of the reactants or products by unit time is called as the average rate of reaction. Okay, so this we can write as a change in concentration of reactants and products. Change in concentration of the reactants and products, okay, or products by unit time. Unit time is called as the average rate of reaction. Okay, so how we are going to represent the average rate of reaction means here delta R divided by delta T. Delta R divided by delta T. Delta R divided by delta T can be represented with the minus is equal to delta P by delta T. Okay, so this is only we can represent in the graph also. Okay, how we can represent the graphically? First, we are taking the concentration on the y-axis, time on the x-axis, time on the x-axis. Which one I can explain here? Can I take the concentration of the reactants or can I take the concentration of the products I can take? Which one I can take, Ritu?
Concentration of reactions.
Concentration of the reactants we can take here. Okay. Now, if the time is going to be increases, concentration of the reactant is going to be decreases or increases, ma? The time is going to be increased in a chemical reaction. If the time is increases, concentration of the reactant is going to be increases or decreases.
Decreases.
Very good one. So decreases means, so this is the highest concentration. Let us see this part. So this part we can consider as an initial concentration. Okay, that we are considering this as a R1. Initial concentration I'm taking as a R1. Now, slowly by increasing the time, concentration of the reactant is going to be decreases. Okay, now wherever you got here, this one. So this part. So this part we can call as this, you consider it as a R1. Okay, and this part you can consider it as a R2. Okay, now this is the initial time. So this we can take as an initial time. Initial time we are taking as a T1 and final time by reaching until here. So what is the time means we can take as a T2. Average rate of reaction. What is mean the average rate of reaction? Change in concentration of the reactant. Change in concentration of the reactant can be represented with the delta R. For this, according to this one, how we can write the formula? Minus of R2 minus R1 divided by T2 minus T1. Okay, T2 minus T1. So this only it represents as, that means this part, how much it is changes. So that part is represents. Okay, whatever the change in this one it is there, that part is represents only we can call as a average rate of reaction. Got it, everyone? Still anyone you're having doubt? Same thing also we can write for the products also now. Same graphical represent also we can write for the products also. If you want to explain for the products means I can explain here. Okay, first in this one I'm taking as reactants on the y-axis. Time I'm taking on the x-axis. Okay, time I'm taking in the x-axis. This one is the concentration. Okay, if we take the products with respect to the products, if the time is increases, concentration of the products is going to be increases. We'll get this graph. This is the initial concentration. This is the R1. And for example, if you want to find out the concentration until here, okay, until here. So this one, these two we can call as a R2. So in between these two, whatever it is there, okay, This part is called as a change in concentration. That how we are writing is here. So this one P1, P2. This one is the P1. This one is P2. According to that one, how we can write change in products? Change in products can be represented with the delta P. Change in time can be represented with the delta T. So this we can call as initial time T1. Okay. This we can consider it as a T2 time. Okay. According to that one, how we can write the formula? Delta P is nothing but change in means final value minus initial value. So P2 minus P1 by, so final time minus initial time, T2 minus T1. Got the clarity? Both here, average rate of reaction means particular time you are taking. Whatever the time it is there, that is only we can call as a change in time. That is only we are taking as a particular time. Okay. Clear? And instantaneous, instantaneous, how you are representing dx by dt. Okay, what is meant by the instantaneous means here a small change in the concentration of the reactant or products by a small interval of time. Okay, that is only we can call as here. So instantaneous. So one more example I'll tell you in your words how I can make as a to how I'll make you understand to average rate of reaction or instantaneous rate of reaction. Some example. Okay, here somebody they are staying as a Dilshuk Nagar. Okay, their college is Koti. Their college is at Koti. Okay, so to reach college, they are using as a different methods. Somebody they can go by bike, somebody they can go by bus. Okay, for example, if you go on to go by bus, how much time to take to reach your college from Dilshuk Nagar to Koti by bus? How much time we can say, ma? You all are from Hyderabad only, na? I think so everyone knows Dilshuk Nagar and Koti. You know or you don't know?
Yes, sir.
Aditi, Ritu. Okay. Approximately how much time we can take to reach Koti Women's College? From
One
Dilshuk
and a
Nagar.
half hour.
1.5 hour, that much of traffic is there nowadays?
I don't know, sir. I've never been to
Sir,
that.
on Saturday, I think it will take 1.5 hours.
Saturday you will take 1.5 hours, Sai Akshit. Okay. And remaining days, working days also, ma. College timings. College timings I'm talking about.
Sir,
I think it will be 1 hour, sir.
3 hours.
Hardly 1 hour. So because of I also studied in Nallakunta, Vidyanagar. So I used to stay in LB Nagar. Okay. So I used to go from Dilshuk Nagar to Nallakunta means hardly I used to take some 1 hour, 15 minutes like that here. Okay. But Dilshuk Nagar means nowadays depends upon the traffic and average time depends upon the traffic and all. If you tell means if you take means here average time you are taking as a 1 hour. That is by bus. If you go by bike means if you go by bike means if the time is going to be reduced or time is going to be increased.
Sir, it will reduce.
It will reduce. Obviously, this is going to be reduced here. Okay. So, sir, how you're telling the time and at all means here, all these criteria is depends upon the speed also. Got the point here? Okay. So, how the time is going to be increases, decreases. If the distance is same, if the distance is same, so reaching within a time, that is the criteria. So that it is depends upon the speed. Okay, that is depends upon the speed. You're telling that by bus is maintaining some speed. Okay, so bike we will maintain some speed. So in bike means we'll get as more speed. Around we are maintaining as some 60 kilometers per hour. Bus people are they can maintain within the city means they'll maintain as some 30-40 kilometers per speed over here. Is it right? Okay, so based on the speed, so reaching time also is going to be changes. So if you go by bike means you are telling that 45 minutes it will take. If you go by bus means you are telling that it takes some 1 hour time. How much time difference you are getting? Almost all 15 to 20 minutes difference you will get easily. Will get or not? Will get or not, sir? Okay, sir, how you are calculating this one means here distance. Distance means here starting place and ending place. How we are going to calculate means here starting place and ending place. Distance, speed, time is there. Okay. Similarly, average rate of reaction. Average means if we want to reach from one place to another place in a particular time, the time only we are taking as a average. For example, instantaneous. What is meant by the instantaneous reaction means? For example, you started the bike from Dilshuk Nagar to Koti. Okay. Suddenly, if somebody they called, one of your friend they called. Okay. One of the friend calls and they're asking, hey, where are you? Okay. So, bro, where are you means you tell immediately. So, you'll tell some particular location. Na? Exactly, you'll tell the location because of you know the exact point here. Okay. Is any possibility is that to tell the exact location by riding of the bike? Is any possibility is there to tell exact location while driving the bike? Okay. Is any possibility is there? Sai Akshit? Sai Akshit, is any possibility is that to tell the exact location by riding?
No, sir.
No, ma. It
No,
is
sir.
impossible. Okay, it is impossible also. Okay, so because of your in traveling, that time if somebody that call means here, so we can't say because immediately you're me. But one thing we can say, one thing we can say. What we can say? We can say the speed. We can say the speed or not? We can say the speed or not? Everyone. Because of everyone nowadays, digital speedometers only, na? Nowadays, everyone, whatever the bikes and all you are using, all are having digital speedometers or not?
Yes,
Okay.
sir.
So while riding, somebody they call, Ritu's friend is called. So how much, what is the speed you are maintaining means we can see and tell na. Because we know we are observing in speedometer. Okay. If they ask, so what is your maintaining the speed means easily you can take I'm maintaining some 60 kilometers speed per hour or 50 kilometers speed hour. Okay. Then what you are doing instantly you are telling that. Instantly. Okay. So instantly you are telling that exact value here. Okay. So in small interval of time, whatever you are measuring, that is only we can call as instantaneous. Okay. So here also we have two types of the reaction. One is the average reaction. Another one is here instantaneous reaction. That means, so in while chemical reaction, okay, during the chemical reaction, at any one particular point, we can calculate the change in concentration of the reactant also. Okay. For example, let's say this is the graph we wrote. In this one, product concentration is going to be increases. If you want to calculate the concentration at this particular point means we can calculate at this particular point. Okay. We can calculate concentration at this particular point also. Wherever you're going to calculate at one particular point, that we can call as a say instantaneous reaction. Instantaneous reactions can be represented by dx by dt. Okay, small interval, small change in the concentration of the reactants or products by small interval of the time is called as a instantaneous rate of reaction. Got it? All of you understood? All of you understood or not?
So it's just basically delta R by delta minus delta R by delta T.
Come on, come again, Samhita.
Instantaneous rate of reaction is minus delta R by delta T.
Minus
Delta R by delta T.
it is average reaction, my dear. Delta R by delta T is represented as a average rate of reaction. Okay, instantaneous means dx dr by dt minus
Oh,
dr
yes,
by
sir.
dt.
Yes, sir. I got
Okay,
confused.
minus dr by dt. Okay, or minus d plus dp by dt plus dp by dt. Okay. So still any confusion is there? Then I'll write the formula here only. Okay. So this also we can write for the instantaneous reaction. Change in concentration of the reactants means that we can write as a dr by dt. We can write small interval. Okay, small interval we are taking here. Small interval minus dr by dt is equal to dp by dt. So this is the representation for the instantaneous reaction. Okay, so this is the representation for the average rate of reaction. Got it? And rate expression. So some more important point is that if you see previous papers also, they're asking some question based on the average rate of reaction. Sorry, the rate representation. Rate representation. Representation of the rate of reaction. Okay, another important concept here, rate expression. Rate expression. Okay, so rate expression. Rate expression. Rate expression. Okay, how we are going to express the rate? Okay, for example, if they had given one chemical reaction, okay, they had given us a one chemical reaction. I'm writing as a one chemical reaction, 1 mole of the hydrogen. It is reacts with 1 mole, or I can take as a half mole, or better I can take as a 1 mole only. So 1 mole of the hydrogen is reacts with 1 mole of the hydrogen gas is reacts with 1 mole of the iodine gas. It forms 2 moles of the hydrogen iodide gas. How many moles it is formed? 2 moles of the hydrogen iodide gas it is formed. Okay, for this one we have to write the rate expression. For this one we have to write the rate expression. Sir, how we can write the rate expression means here? So first, okay, how we can write the rate expression means clearly. So in a rate expression, change in concentration of the reactants is equal to change in concentration of the products. Okay, change in concentration of the reactants is equal to change in concentration of the products, and the concentration is divided by the respective stoichiometric coefficients. Can I repeat once again statement here? Can I repeat once again statement by here? Change in concentration of the reactants is equal to change in concentration of the products, and their concentrations are divided by the respective stoichiometric coefficients. Got it? Clarity the statement? Everyone? Samhita, Ritu, Sai, Akshit, okay, Kathy, Aditi, you got the statement clearly?
Yes, sir.
Yes,
Right.
sir.
So according to that one, now I'm writing as a representation. So how many moles it is there, ma? How many moles of the hydrogen we had taken? 1 mole. Okay. So what is the stoichiometric coefficients, ma? What is the stoichiometric coefficients in the given reaction, ma? Can you tell me the stoichiometric coefficients here for hydrogen? What is the stoichiometric coefficient of the hydrogen? 1. What is the stoichiometric coefficient of the iodine? 1. What is the stoichiometric coefficient of the hydrogen iodide? 2. Okay, stoichiometric coefficient of the hydrogen iodide is equal to 2. So before the molecular formula, how many moles it is forming? That is what we can consider it as a stoichiometric coefficient. Okay, clear? According to that, how we can write the rate expression? So rate expression. So reactants. For reactants, rate of reaction is change in concentration of the reactant. Change in concentration of the reactants can be represented with the minus, and we can represent as a delta. So delta molar concentration of the H2 divided by, okay, molar concentration, sorry, dt plus dt is equal to, and what is here? Change in concentration of the iodine. What is the stoichiometry of the iodine? It is that 1 only. 1 by 1. We can write as a 1 by 1. Here also we can write as a 1 by 1. Change in concentration of the iodine. Delta I2 divided by delta T. Okay. Next is equal to. So products. Products we can represent with the positive sign or negative sign, ma? Change in products. Change in concentration of the products we can represent with the positive sign or negative sign. Aditi? Aditi, how we can represent change in concentration of the products? Ritu?
So can you repeat the question again?
Not
How?
positive sign.
Very good, ma. So how we can represent the change in concentration of the products?
Sir, it will be positive increasing.
Very good one. So it is the positive. So that means we need not to represent any sign. Sometimes we may mention, we may not mention also, no problem. So generally we can represent with the positive. So that means delta hi. Okay. So that means 1 by 2 into delta hi divided by delta t. So this is the rate expression of the following equation. All of you understood? Can I repeat once again here? I'll give some examples. You have to solve that examples here. Okay? Right, ma? So this is the rate expression. So rate expression, in a rate expression, molar concentration, change in concentration of the reactants is equal to change in concentration of the product divided by their stoichiometric coefficients. Now you got the clarity. According to that one, we can write as a rate expression. By using the rate expression, if we know the concentration of the one reactant, one element, we can find out the concentration of the another one also. We can calculate or not? Okay. So we can calculate or not. If we know the concentration of the one element means, so we can calculate the concentration of the another element also. First, you have to know how to write the rate expression. For example, if I give one more example here. So another example I had given. For example, 1 mole of the nitrogen gas. 1 mole of the nitrogen gas reacts with 3 moles of the hydrogen gas. It forms 2 moles of the ammonia gas. 2 moles of the ammonia gas. Who's going to write the rate expression for this one? What is the rate expression of the following reaction? Any one of you. What is the rate expression of the following reaction? How we can write this one? I will give some JEE question also. Based on this. What is the answer, ma? Who was giving these answers? How we can write the rate expression? I'm searching for the JEE question. How we can write, ma? No one is giving the answer. Yeah, they had given some reaction. How we can write, Aditi, Ritu? But first, what are the reactants and what are the products? Which one are the
N2 and
reactants?
3H2 are reacting, sir.
Nitrogen and hydrogen are the reactants here. Ammonia is the product.
Yes.
Okay. So this one react while writing the reactants. How we can write? Minus of delta N2 divided by delta T is equal to, here because of I didn't write anything, ma. Stoichiometric coefficient I didn't take. Because of, you'll get a stoichiometric coefficient of the nitrogen is equal to 1. What is the stoichiometric coefficient of the hydrogen? What is the stoichiometric coefficient of the hydrogen, ma?
1, sir.
Hydrogen, ma. Before the hydrogen, how many moles it is there?
3, sir.
3. So
Yes,
that means
sir.
how we can write is here minus of 1 by 3 delta H2 divided by delta T. And what is the stoichiometric coefficient of the ammonia? This is stoichiometric coefficient of the ammonia, ma. This is the stoichiometric coefficient of the ammonia. This is the stoichiometric coefficient of the ammonia. 2 ma. So according to that one, how we can write? While writing the products, we can write as a 1 by 2. So delta NH3 divided by delta T. For the clarity, can I give one more example to make you perfect? Ma? What is another example? I'm giving one more example here. What is another example? Means here 2 moles of the NO. Ma. Okay, 2 moles of NO. 2 moles of NO, nitric oxide gas. It reacts with 1 mole of the chlorine gas. Reacts with 1 mole of the chlorine gas. It forms 2 moles of the NOCl, nitrosyl chloride. Okay. For this one, how we can write as a rate expression? For this one, how we can write as a rate expression? One question is there. We have a calculations also based on this concept. That's why I'm going very slowly. Calculations are there, man. How we can write? Any one of you? What is answering? Here it is. I got the JEE question, previous JEE question. What is the answer for this one? Can you make it fast? So this we can write as a minus of 1 by 2 delta NO divided by delta T is equal to, okay. So here minus of delta Cl2 divided by delta T is equal to 1 by 2 delta NOCl divided by delta T. Okay, so this is previous JEE question mark. So what is the previous JEE question? Means here 5 moles of the Br minus, 5 moles of the Br minus, aqueous solution of the Br minus, okay, plus BrO3 minus, plus BrO3 minus aqueous medium, okay, plus 6 moles of H plus gives rise to 3 moles of the Br2, 3 moles of Br2 plus 3 moles of the water molecule, plus 3 moles of the water molecule. So write the rate expression, ma. Right? Rate expression. Write the rate expression. Any one of it. This is the previous JEE question, ma. This is the previous JEE question. Kathy, somebody left. Who left? Sai Akshita? I think so. Time up. That's why he left. All of you do one thing. Okay. Anyone? Can you give the answer for this one? Kathy, Aditi, Samhita, Ritu. First, you have to check it out the stoichiometric coefficients. My question is, what are the stoichiometric coefficients for the bromide ion? Br minus, what is the stoichiometric coefficient? Ritu? Ritu, what is the stoichiometric coefficient of the Br minus?
5, sir.
5, Kathy. Very good, Kathy. And what is the stoichiometric coefficient of the BrO3 minus?
1.
1. Okay. What is the stoichiometric coefficient of the H plus ions?
Sir, do we count for that?
6, ma. 6
Okay,
only.
okay.
Before whatever it is there, before the ion, whatever the number it is there, that is when it becomes as a stoichiometric coefficient. Okay. And what is the Br2? Br2, what is the stoichiometric coefficient of the Br2? Means 3. What is the stoichiometric coefficient of the water molecule? Means 3. According to that one, how we can write the equation? First one, finish one. Minus of 1 by 5 delta BR minus by delta T. It is the previous question mark. Minus delta BR O3 minus by delta T is equal to minus of 1 by 6 delta H plus divided by delta T is equal to 1 by 3 delta BR2 divided by delta T is equal to 1 by 3 delta change in concentration, so molar concentration of the water molecule by delta T, change in time. This is the expression. This is the expression exactly. But in this one, with respect to comparison, they ask the question. Comparison, they ask the question. I will show that question also. Okay, that part we will discuss in the next class. Hope so you are having next class now. At what time you are having the class?
8:40, sir.
8:40, yeah. Okay, ma'am. So if you see means some previous papers are there, means in that one clearly they ask this question. Based on this one also we are having some of the numericals. Okay, to find out the numerical means first you have to know this one. How to write the rate expression, that you have to know. Without writing the rate expression, it is not possible to calculate also. Okay, we will do some numericals based on this one tomorrow. Okay, ma'am.
Okay, sir.
Then we'll continue in the next class. All of you, everyone, you understood now until here?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
So thank you all.
Thank you, sir.
Thank you, sir.